Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over some techniques to help you remember the trigonometric differentiation and integration rules. So, to help you remember the trig differentiation and integration rules, you have to first of all remember what your 6 trig functions are. Okay? So, let's call that back to mind. Let's recall all the 6 trig functions. Alright, so what are the 6 trig functions? The 6 trig functions are sine x, we have cosine x, these are the parent trig functions. Sine over cosine will give you the first quotient identity, which is tan. If you reciprocate tan, you get cotangent. When you reciprocate cosine, you get secant x. And then when you reciprocate sine, you get cosecant x. Okay, so these are the 6 trig functions that we need to know the derivatives of. And from the derivatives of this 6 trig functions, you can find the integral of those derivatives by simply reversing the differentiation process. Alright, we're going to start out with the derivatives, the differentiation rules for the 6 trig functions that we just mentioned. So we're going to start with sine x. So what's the derivative of sine x? You want to start with this one, okay? The derivative of sine x is cosine x. Now, why is this a good starting point? Well, if you know the derivative of sine x, the derivative of cosine x is somewhat similar, but there's a reversal of sign. So the derivative of cosine x is going to be negative sine x. Okay? So don't forget, the derivative of sine is cosine, and the derivative of cosine is negative sine. Notice how the c in the name of this trig function is associated with negativity. Now let's move on to the next one, which is the tan function. The derivative of tan x is secant square x. Just visualize cosine and its reciprocal. The reciprocal of cosine is secant, right? So you're simply squaring the reciprocal of cosine, which is secant square x. Now this is number 3. For 4, we have the reciprocal of tan, which is cotangent x. The derivative of cotangent, can you guess what it is? For secant, we reciprocated this and squared it. Here, the derivative of cotangent will reciprocate sine, which is cosecant x, and we'll square it also. Okay? But there's also negative. You see how the derivative of this trig function that starts with a c, you'll also have a negative there. Now let's take a look at number 5. The reciprocal identities for cosine and sine. Let's start with secant x. Supposed to be prime here. The derivative of secant x is secant x tan x. So with this setup we have here in number 3, is just as though we were pulling down these 2 trig functions. Secant, you're just pulling down secant and tan, put them together, and you have the derivative. Secant x tan x is a derivative of secant x. And then we have the last one, the reciprocal of sine, which is cosecant. The derivative of cosecant x, can you guess what it's going to be? It's just a combination of these two, right? Cosecant and cotangent. Cosecant x, cotangent x. But notice this function starts with a c also. Can you guess how that will impact this result right here? It's going to have a negative. Okay? So remember, when you're differentiating the trig functions that start with c's, you always end up with a negative derivative. Alright, now we're gonna switch gears and take a look at the integrals, okay? Um, the integration rules or the integrals for your trig functions. All we are going to be doing here is just simply reversing these differentiation rules, okay? So let's start with the first one. Since the derivative of sine x is cosine x, the integral of cosine x dx, guess what it is? It is sine x. Since this is an indefinite integral, you also have to add that c component. The second one, with these ones that have negative, what we're going to do is just move the negative sign to the left side and integrate, okay? So when I integrate sine x dx, don't forget the dx goes with the integral. You're going to have cosine, okay? But since this was negative and this is now positive, the negativity has switched to the other side, so it's negative cosine x plus c. Number 3. We're now going to integrate secant square x dx. Since the derivative of tan is secant square, the integral of secant square x is tan x plus c. There is no sign change here since there was no sign change when we differentiated. Formula 4. What is the integral of cosecant square x dx? In this case, the integral of cosecant square x is going to be negative cotangent x plus c. There was a sign change when differentiating, so when integrating, the signs will change also. Okay, all we are doing here is just reversing. We're reversing the differentiation rules. Now let's take a look at formula 5, which is the integral of secant x tan x. We know that the derivative of secant is secant x tan x. So that follows that the integral of secant x tan x is going to be secant x plus c. Formula 6. The integral of cosecant x cotangent x dx. The derivative of cosecant x is negative cosecant x cotangent x, so the integral is going to be negative. We'll have a sign change here. Negative cosecant x. And then don't forget your plus c since we have an indefinite integral. Okay? So this just helps us to see that if we want to master all these 12 trigonometric differentiation and integration rules, all we need to do is remember the first 6, and then we'll just reverse the equations to generate the other 6 formulas for integrating your derivatives of trigonometric functions. Thanks so much for taking the time to watch this presentation. If this tutorial helped you to master your formulas for differentiation, don't forget to give us a thumbs up. We appreciate your positive feedback. And also don't forget to subscribe to our channel for updates to other tutorials such as this. If you have any questions or comments about the contents of this presentation, you can just place it in the comment section below, and we'll be glad to address your concerns. Now we have a nice formula sheet containing all the differentiation and integration rules. If you would like to gain access to that document, you simply go to math.serve.com, and under the AP Calculus page, you will see the differentiation rules sheet, and you will also gain access to a wide variety of AP Calc AV prep resources that will help you pass the AP examination. Thanks again for taking the time to watch this presentation, and have a wonderful day.